According to the National Electrical Code, neck metal-clad MC cable installed in a vertical position must be securely supported at intervals not exceeding 6 feet. However, certain exceptions apply for shorter lengths of MC cable. NEC Section 330.31 C1 states that MC cable less than 6 feet long between fixed points is permitted without support if the cable does not exceed a 24-inch diameter bending radius. To qualify for this exception, the following conditions must be met. Firstly, the MC cable must be installed between two fixed supports, such as light fixtures or junction boxes. Secondly, the cable must not exceed 6 feet in length. Thirdly, the cable must not be subjected to excessive bending or strain. And fourthly, the bending radius must be at least 24 inches. Most experts agree that it is permissible to use MC cable less than 6 feet long between light fixtures without support under the conditions specified in the NEC exception. Some inspectors may require support for MC cable of any length, even if it is less than 6 feet. In areas prone to earthquakes or other seismic activity, additional support may be required, even for short lengths of MC cable. It's recommended to always check with the local electrical authority for specific requirements in your area. If possible, provide support for MC cable of any length to ensure proper cable integrity and prevent potential safety hazards. Always follow the NEC guidelines carefully and consider any additional safety precautions necessary for your specific application. MC cable, short for metal-clad cable, is a type of electrical cable that consists of insulated conductors encased in a flexible metallic sheath. This sheath provides physical protection to the conductors and also serves as a grounding path. MC cable is commonly used in various electrical wiring applications, including residential, commercial, and industrial settings. It's often chosen for its ease of installation and its ability to be run in exposed or concealed locations. When installing MC cable, it's crucial to adhere to the guidelines and regulations set forth by the NEC and local electrical codes. These codes specify requirements for cable support, securing, and termination to ensure safe and reliable electrical systems. The primary purpose of supporting MC cable is to prevent strain on the conductors and terminations. Without proper support, the weight of the cable can cause it to sag or pull on connections, potentially leading to loose connections, damaged conductors, or even electrical hazards. The NEC provides specific requirements for supporting MC cable based on its size, type, and installation location. As mentioned earlier, a general rule is that MC cable installed in a vertical position must be securely supported at intervals not exceeding 6 feet. This means that the cable must be fastened or supported at least every 6 feet along its vertical run. For horizontal runs, the support requirements may differ depending on the specific code requirements and the type of MC cable being used. In many cases, horizontal runs of MC cable must be supported at intervals of 4.5 feet or less. However, there are exceptions to these general rules, particularly for short lengths of MC cable installed between fixed points. According to NEC Section 330.31, C1, MC cable less than 6 feet long between fixed points is permitted without support if certain conditions are met. The first condition is that the MC cable must be installed between two fixed supports, such as light fixtures or junction boxes. These fixed supports provide a secure anchor for the cable and prevent it from sagging or moving excessively. The second condition is that the cable must not exceed 6 feet in length. This limitation ensures that the weight of the cable is minimal and that any potential strain on the connections is within acceptable limits. The third condition is that the cable must not be subjected to excessive bending or strain. Sharp bends or tight pulling on the cable can damage the conductors or the metallic sheath, compromising the cable's integrity and safety. The fourth condition is that the bending radius must be at least 24 inches. This requirement helps to prevent damage to the conductors and ensures that the cable can be easily installed and maintained. It's important to note that these exceptions for short lengths of MC cable are not universally accepted by all electrical inspectors or authorities. Some inspectors may require support for MC cable of any length, regardless of whether it meets the conditions specified in the NEC exception. This is because they may have concerns about potential safety hazards or long-term reliability, or they may simply interpret the code differently. In areas prone to earthquakes or other seismic activity, additional support may be required for MC cable, even for short lengths. Seismic activity can cause excessive movement and stress on electrical systems, and additional support helps to prevent damage and ensure the safety of occupants. Therefore, it's always a good idea to check with a local electrical authority for specific requirements in your area before installing MC cable without support. They can provide guidance on the applicable codes and regulations and may have additional requirements or recommendations based on local conditions. Even if the NEC exception allows for the installation of MC cable without support, it's often a good practice to provide support whenever possible. Supporting the cable helps to ensure proper cable integrity and prevents potential safety hazards in the long run. Additional support can also help to protect the cable from physical damage and reduce the risk of loose connections or other problems. When providing support for MC cable, it's important to use appropriate methods and materials. The support should be securely fastened to the building structure and should be designed to support the weight of the cable without causing damage. Common methods of supporting MC cable include using cable ties, straps, or clamps. These supports should be installed at appropriate intervals to prevent sagging or excessive movement of the cable. It's also important to ensure that the supports are compatible with the type of MC cable being used. Some supports may not be suitable for certain types of cable, and using the wrong type of support can damage the cable or compromise its integrity. In addition to providing physical support for MC cable, it's also important to follow proper installation practices to ensure the safety and reliability of the electrical system. This includes using the correct size and type of cable for the application, making proper connections, and protecting the cable from damage. When making connections to MC cable, it's important to use connectors that are specifically designed for use with MC cable. These connectors provide a secure and reliable connection between the cable and the electrical equipment. It's also important to ensure that the connectors are properly tightened to prevent loose connections. When running MC cable through walls or floors, it's important to protect the cable from damage. This can be done by using conduit or other protective measures. Conduit provides a physical barrier that protects the cable from abrasion, impact, and other potential hazards. It's also important to seal any openings around the cable to prevent the entry of moisture or pests. In summary, while the NEC does provide an exception for using MC cable less than 6 feet long between fixed points without support, it's important to carefully consider the conditions of the exception and the potential risks involved. It's always a good idea to check with the local electrical authority for specific requirements in your area and to provide support for MC cable whenever possible. By following these guidelines and best practices, you can help to ensure the safety and reliability of your electrical system. Remember that electrical work can be dangerous, and it's always best to consult with a qualified electrician if you have any questions or concerns. A qualified electrician has the knowledge and experience to safely and effectively install and maintain electrical systems. They can also help you to ensure that your electrical system meets all applicable codes and regulations. When working with electrical systems, it's important to always take safety precautions. This includes turning off the power to the circuit before working on it, using insulated tools, and wearing appropriate personal protective equipment. Electrical shock can be deadly, so it's important to take all necessary precautions to protect yourself from harm. In addition to following the NEC and local electrical codes, it's also important to follow the manufacturer's instructions for installing and using MC cable. The manufacturer's instructions may provide additional information or recommendations that are specific to the type of cable being used. By following all applicable guidelines and best practices, you can help to ensure that your electrical system is safe, reliable, and compliant with all applicable codes and regulations. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer for specific advice on your electrical projects. Furthermore, the NEC is a comprehensive document that covers a wide range of electrical topics. It's important to consult the NEC directly for the most accurate and up-to-date information. The NEC is updated every 3 years, so it's important to ensure that you are using the most current edition. The NEC is available for purchase from the National Fire Protection Association, NFPA, and other sources. In addition to the NEC, there may be other local or regional codes and regulations that apply to electrical installations in your area. It's important to check with the local electrical authority to determine which codes and regulations are applicable to your project. The local electrical authority can also provide guidance on specific requirements or recommendations that may be unique to your area. When installing MC cable, it's important to pay attention to the bending radius of the cable. The bending radius is the minimum radius that the cable can be bent without damaging the conductors or the metallic sheath. The NEC specifies minimum bending radii for MC cable based on the size and type of cable. Exceeding the minimum bending radius can damage the cable and compromise its integrity. When making bends in MC cable, it's important to use appropriate tools and techniques. Avoid making sharp bends or kinking the cable. Use a cable bender or other specialized tool to create smooth, consistent bends. It's also important to avoid overbending the cable. Overbending can damage the conductors or the metallic sheath. If you are unsure about the proper bending radius for a particular type of MC cable, consult the manufacturer's instructions or the NEC. When installing MC cable in damp or wet locations, it's important to use cable that is specifically listed for use in those locations. Wet location MC cable is designed to resist moisture and corrosion. It typically has a special outer jacket that protects the conductors from moisture. When installing MC cable in corrosive environments, it's important to use cable that is specifically listed for use in those environments. Corrosive environment MC cable is designed to resist corrosion from chemicals, salt water, and other corrosive substances. It typically has a special outer jacket and corrosion-resistant connectors. When installing MC cable in hazardous locations, it's important to use cable that is specifically listed for use in those locations. Hazardous locations are areas where there is a risk of explosion or fire due to the presence of flammable gases, vapors, or dusts. Hazardous location MC cable is designed to prevent the ignition of these flammable substances. It typically has a special outer jacket and explosion-proof connectors. When installing MC cable near sources of heat, it's important to use cable that is specifically listed for use in those locations. Heat-resistant MC cable is designed to withstand high temperatures without degrading. It typically has a special outer jacket that is resistant to heat. When installing MC cable underground, it's important to use cable that is specifically listed for use in underground applications. Underground MC cable is designed to resist moisture, corrosion, and physical damage. It typically has a special outer jacket and is installed in conduit. When installing MC cable in concrete, it's important to use cable that is specifically listed for use in concrete. Concrete encased MC cable is designed to resist corrosion from the concrete. It typically has a special outer jacket and is installed in conduit. When installing MC cable in fire-rated assemblies, it's important to use cable that is specifically listed for use in fire-rated assemblies. Fire-rated MC cable is designed to maintain its integrity during a fire. It typically has a special outer jacket and is tested to meet specific fire resistance standards. When installing MC cable, it's important to avoid damaging the cable. Damaged cable can be a safety hazard. If you damage MC cable, replace it with new cable. Do not attempt to repair damaged MC cable. When installing MC cable, it's important to avoid pulling the cable too tightly. Pulling the cable too tightly can damage the conductors or the metallic sheath. Use a cable puller or other specialized tool to pull the cable without damaging it. When installing MC cable, it's important to avoid twisting the cable. Twisting the cable can damage the conductors or the metallic sheath. Use a cable swivel or other specialized tool to prevent the cable from twisting. When installing MC cable, it's important to avoid kinking the cable. Kinking the cable can damage the conductors or the metallic sheath. Use a cable bender or other specialized tool to make smooth, consistent bends. When installing MC cable, it's important to avoid overbending the cable. Overbending the cable can damage the conductors or the metallic sheath. Consult the manufacturer's instructions or the NEC for the minimum bending radius. When installing MC cable, it's important to avoid stepping on the cable. Stepping on the cable can damage the conductors or the metallic sheath. Protect the cable from foot traffic. When installing MC cable, it's important to avoid driving nails or screws into the cable. Driving nails or screws into the cable can damage the conductors or the metallic sheath. Protect the cable from nails and screws. When installing MC cable, it's important to avoid exposing the cable to sharp objects. Sharp objects can damage the conductors or the metallic sheath. Protect the cable from sharp objects. When installing MC cable, it's important to avoid exposing the cable to chemicals. Chemicals can damage the conductors or the metallic sheath. Protect the cable from chemicals. When installing MC cable, it's important to avoid exposing the cable to excessive heat. Excessive heat can damage the conductors or the metallic sheath. Protect the cable from excessive heat. When installing MC cable, it's important to avoid exposing the cable to excessive moisture. Excessive moisture can damage the conductors or the metallic sheath. Protect the cable from excessive moisture. Always adhere to local regulations.